In May 2015, a software engineer named Jackie Ellison opened Google Photos and found the app had sorted pictures of him and a friend, both black, into an album named Gorillas. Yikes. In this video, I want to dig into the technologies behind that, how it was built, what it actually is, why the businesses cared about it, and how would you design something like that yourself. So let's begin. Images are one of the most common forms of data we generate, and for most of computing history, none of it was usable. By late 2020, Google Photos was holding more than 4 trillion photos and taking in another 28 billion every week. Across the world, we're now taking somewhere around 2 trillion photos a year, about 94% of them on phones. And you couldn't search any of it. You couldn't ask it anything. If you wanted the photo of your dog at the beach from 2014, you scrolled until you found it. Apple was sitting on the same archive with the same problem. Then comes ImageNet. ImageNet started in 2009. Fei-Fei Li's argument at the time was that the whole field had it backwards. Everyone was trying to build better algorithms, and she thought that the thing actually holding vision back was the data. So ImageNet was built to hold millions of images organized into categories borrowed from WordNet. The competition, ILS-VRC, started in 2010, using 1,000 class subset of 1.2 million images. The first 2 years were won by hand-engineered feature methods, and the error rates barely moved between them. Then, in 2012, Krzyzewski, Sutskever, and Hinton entered the competition with their convolutional neural network trained on those 1.2 million images. It won with a 15.3% top 5 error rate. Second place, a non-deep learning entry, was at 26.2%. As you can see, that's not just an improvement. That's a whole different category of result on its own, and everyone in the field noticed. So, what does this mean for businesses? Apple, Amazon, eBay, and Meta were all already enormous at this time before any of this happened. None of them were rescued or were looking for a better computer vision algorithm. So let's look at this. To analyze this, I've bucketed what came out of this in 3 ways: accessibility products, product improvements, and entirely new products on its own. Let's look at accessibility. So in 2016, Meta had around 2 billion photos a day that were moving around Facebook, Instagram, Messenger, and WhatsApp. Around 39 million blind people and another 246 million with severe visual impairment were all locked out of it. They had a screen reader which would hit a photo, announce photo, and then stop. So they built an automatic alt text, a description generated for every image and read out by the screen reader. The first version was fewer than 100 concepts, and every one of them had to clear a minimum precision of 0.8, some as high as 0.99. They chose to describe less and be right rather than describe more and be wrong. The 2021 revamp took it from around 100 objects to around 1,200 objects. What this resulted: a controlled 2-week study, 9,000 voiceover users split randomly into test and control. The test group found photos easier to interpret, more engaging, and Facebook more useful overall because of this new feature. Microsoft went after the same users from a different point of view. Meta's version was passive. It described what was already in your feed, but Microsoft Seeing AI was more active. You point your camera at a document, a bus stop, a banknote, and it tells you what's there, running entirely on the device. So Microsoft used the same technology, but just a completely different product decision, and it resulted over 100,000 downloads and more than 10 million tasks assisted. So this shows us that two very big tech giants and how they captured the power of ImageNet and improved their existing product. Now let's look at product improvements. Google Photos and Lens is finally searchable. They described noticing that people were struggling to manage their photos and videos, and finding a specific photo generally was hard. That's the observation the whole product was built on. Type dog, you get pictures of your dog. Lens extended it to camera, so the thing in front of you becomes queryable. Lens is now handling roughly 20 billion searches a month, about 4 times its 2021 volume, with around 1/5 of those being shopping related, which is backed by 45 billion product catalog. Apple built the same feature and made the opposite architectural bet. The recognition runs entirely on device on the neural engine, because their whole position is that your photos don't leave your phone. Apple has never published usage numbers for this, but the only figure they released is an engineering one: end-to-end face recognition under 4 milliseconds, roughly 8 times faster doing it on the GPU, which is what they were going for. eBay launched image search in 2017, across what was then about 1.1 billion listings, later around 1.9 billion, which roughly had 2.1 billion images attached. Their hard problem was a lot of noise. Most of those photos are somebody's used drill on a kitchen table, not a clean catalog shot, and the model has to figure out how to distinguish that. Amazon's style snap went after fashion. Pinterest had already shipped lens and proven people would do this. Amazon wasn't guessing at demand. They were watching competitor demonstrate it, which is where text search fails hardest. You can describe a product, but you can't describe a style or aesthetic, and which also happens to be the highest purchase intent category there is. Snapchat scan is one where the behavior already existed. Snapchat users opened the camera by default. The camera just wasn't doing anything with what it's up. So they made a press and hold a feature where you can identify clothes, dog breeds, plants, cars, solve math problems, and hand barcodes off to Amazon. After studying these use cases, one takeaway for me is that any product enhancement should really be based on a customer journey on your platform. eBay, Amazon, and Snapchat benefited from their current users just having an easier experience, whereas Apple, Google, Microsoft, and Meta either introduced new users or gave new things to their existing users so that they use the product more in a more frictionless manner. Now, let's look at some new products. First of all, Pinterest. For Pinterest, this wasn't a feature, it was their entire product. Pinterest is a discovery engine, not a text search engine, and most of what's on it isn't well described by words. You don't want a lamp, you want a specific aesthetic lamp, and there was no way to type that. You could only show pictures of it. So what did they build? They fine-tuned a VGG model, ran a billion pins through it, pulled a layer of numbers out of each one, and indexed all of it into a distributed service. Then they put a cropper on top. You drag a box over a part of a pin and get visually similar pins back. That was their whole first version. Everything after that was just more improvements. Object detection, so you don't have to draw the box yourself. A lot of generic embeddings weren't good enough for fashion. Visual similarity alone will happily show you blue stripes when you ask for red or green. So they trained extra heads specifically for color, pattern, texture, and material. And now today, roughly 631 million monthly active users, around 80 billion visual searches a month, up 44% year over year, 4.2 billion in FY 2025 revenue, and their first billion dollar quarter in Q1 2026. And those embeddings ended up feeding their recommender too as well. So the same work made the main feed better. Another product example is John Deere's See and Spray. The problem is that when you spray a field for weeds, you spray the entire field, even though only a fraction of it has weeds. Every season, measurable in gallons and dollar per acre. Deere bought a company called Blue River Technology for $305 million. What runs now is a sprayer with 36 cameras scanning over 2,500 square feet every second at up to 16 miles an hour, deciding weed or crop in real time and spraying only the weeds. Roughly 50 to 59% less herbicide. About 31 million gallons saved across 5 million acres in 2025. Now that we have all these business acumen knowledge, now let's see how do we actually build this up from ground up. Now that we have all of that business knowledge, let's actually learn how to take an image to that entire technology and see what we come up with. Let's start with an image that is 224 pixels by 224 pixels, 3 color channels for red, green. That's 150,528 numbers, and those numbers are all the network ever sees. There's no concept of a lamp, dog, or anything here yet. First layer, we take a 3x3 grid of weights and lay it over the top left corner of the image. Multiply each weight by the pixel underneath it. Add the 9 results together and write down that number. Then slide over by 1 pixel and do it again and again until you cover the whole image. What you end up with is a new grid, where every value says how strongly that patch of the photo matched that particular filter. Now do that with 64 different filters. You came in with 224 by 224 by 3. You come out with 224 by 224 by 64. Those 64 filters are not hand-coded. Those 64 filters are purely learned by a technology called gradient descent. What they converge to are edge detectors at different angles plus color transitions. You can visualize them and they look a lot like what people were hand-coding in 2005. Then we pass it through a ReLU function. A ReLU function is a very simple function that basically turns anything that's negative to a 0 and everything else just passes through. This stops the whole stack from collapsing into one big linear function. Then we apply pooling. Take every 2x2 square, keep only the largest number. Throw the other 3 away. So 224 becomes 112 by 112. You just lost 3/4 of your spatial information on purpose. Now you do this, we repeat that block 5 times. The picture keeps getting smaller and the stack gets deeper in every single block. The first layer knows exactly where the edges are, but has no idea what it's looking at. But the last layer has no idea where anything is, but it knows that it's a lamp. The same 3x3 filter runs at every position. It learns a feature, not a feature, at pixel 47. That's the hand-engineered rule that we overcame right there. At the end, you've got a 7x7 by 512. Flatten that out, and it's 25,088 numbers in a row. One fully connected layer takes it down to 4,096. Another one keeps it at 4,096. And the final one takes it to 1,000. One output for every ImageNet category, whichever is the highest is the answer. That's it. Now you have a fully convolutional neural network that you took a picture through to get a classification at the end. Once you can turn images into numbers, almost every image product is some arrangement of the same 4 operations. What are they? So once the image comes in, you can either classify the image, segment the image, retrieve some info about the image, or find similar images. So let's kind of break these down a bit more. Classify. Classify is what we just built. You pass in an image and you try to figure out what that image represents. Segmentation is a where problem, not a what problem. You want to draw boundaries around a specific object, a box or a pixel by pixel. Retrieve is looking things up. You've isolated a region, now match it against a catalog or a knowledge graph to find out what it actually is and what it costs. Google Lens 45 billion product graph is the stage. And lastly, similarity. Similarity is finding the neighbors. Turn it into a vector, search for the closest other vectors. So essentially, if you're trying to find similar images to the one you're interested in. So now let's think about this entire thing in terms of systems. Let's walk through the system design for a solution like this. So the functional requirements. Users upload images and the system should be able to index them without anyone tagging anything. Users searches for an image via text, retrieves the relevant images. And users search for an image by an image, including cropping a region and searching inside it. The non-functional requirements. Search has to come back in under about a half a second at P99. A newly uploaded photo should be searchable within minutes. It needs to handle billions of images and tens of thousands of queries a second. And the cost per image indexed has to be bounded, because that scales with your collection whether anyone uses the feature or not. The real numbers for the non-functional requirements can vary depending on your system, but high level, you should think about these when designing this system. The entities. The entities are an image, an embedding, a label, a user, and a search query. The interface is basically 3 endpoints: one to upload, one to search by text, one to search by image, and bounding box. Now the actual system. There are 3 paths through this: the upload path, the indexing path, and the query path. Let's go through each of them. The upload path. Client hits the API, the file goes into an object storage. You write a metadata row, and you drop an event on a queue saying new image has arrived. That's it. Respond back to the user. The indexing path. The indexing path picks that event up. A pool of workers pulls from the queue, runs the encoder on a GPU, and writes the resulting vector into the vector index and any labels into the metadata row. The query path. A text query gets encoded into the same vector space, and image query goes through the image encoder. Approximate nearest neighbor search against the index. Then a filter pass against metadata for things like ownership and date. Then we re-rank the top handful results properly. That's the high-level skeleton. If you want to go deeper on any single piece here, I will recommend some further readings in the description. But high-level, eBay's architecture paper is really good. Pinterest's engineering paper is also really good. And Hello Interview is one of the best platforms to go and learn about system design for any solutions. So we understand the business, we understand the technology, and we know roughly how to build it. The question left is, how would you know whether what you're building is working? Like, what metrics do we look at here? So for me, I think search volume, adoption, quality are key things to look at. So search volume is the most obvious one, and it's also the weakest one because it only tells you that people have tried something. For adoption, look at the share of sessions that use visual search at least once, and the repeat rate for it as well. Do the same people come back to it and try it once and never again? For quality, the useful ones are your 0 result rate, your abandonment rate after results come back, and click position. If people are consistently clicking the 7th result, your ranking is wrong, even though your recall is fine. Query reformulation matters too. Somebody searching again immediately means the first attempt failed. And there's also a point to be made about looking at downstream. So the downstream, which depends on what you're building. For commerce, it's conversion on visual search sessions versus text search sessions at comparable intent. For a photo library, it's time to find. And let's pause on there for a second, because it's a metric where the number going down is the win. You want less people to be going through their photos library app to find, because you want them to be able to find their image as quickly as possible. So now, how do we decide whether to invest in this at all? And how would you roll this out? I was trying to find actual financial data for Pinterest, eBay, Google, and all these companies in terms of what they had allocated, how much revenue did this all bring, but there wasn't that much public information. But what we did have is the following. Pinterest, 80 billion visual searches a month, up 44% year over year. First $1 billion quarter in Q1 2026. Google Lens, 20 billion searches a month, 4 times what it was 3 years ago. John Deere, 31 million gallons of herbicides saved in a single season. So these are very good numbers, and these kind of tell that, hey, what they did was pretty good. So now, how do you know if you do need to allocate and devote a core engineer or engineering team behind building up a imaging system like this? I had touched on this earlier in the video, but it's good to kind of go a bit deeper into this. So the way I would like to think about it is as follows. Take your product and your customer and think about it from first principles. What's the lowest friction way for someone to interact with the thing you've built? If an image genuinely lowers that friction, then it's worth doing. 3 situations where it's very clear. When the user's intent can't be typed. That's where Pinterest really won. You can't necessarily type, hey, I want a shirt that fits this aesthetic. You would want to show a picture of that aesthetic or a shirt that already exists. When your catalog changes very fast, then anyone could ever tag it. That was eBay's premise. And when the decision has to happen in the physical world in real time, which was the see and spray problem. Once you've kind of understood, okay, there might be a need for this, how do you kind of plan out? What does the roadmap look like for this? Every project should have an immediate version, a middle version, and a long-term vision. That's what lets you learn as you go instead of building something nobody asked for. Whichever those 4, so there are 4 buckets to this. There's axis, scope, depth. Oh my god. So how would you roll this out? Every project should have an immediate version, a middle version, and a long-term version. That's what lets you learn as you go instead of building something nobody asked for. So there's whichever those 4 buckets you're in, and you're moving along 4 different axes. And the rule is to move one at a time. So the axes are scope, depth, quality, and latency. So for scope, 1 category or a slice of the catalog, and then eventually to all of it. For depth, 1 pipeline stage. For quality, off-the-shelf pre-trained model are your best way to go. For latency, batch is usually the right answer. Now let's kind of look at the different versions that we talked about. So for right now, take the single stage that carries your value and run it on the narrowest slice you can. Defend. Off-the-shelf model, no fine-tuning, ship it to a subset of users. You're testing whether anyone really wants this and is finding value from this. Then, soon after, widen the scope, not the depth. Same stage, more of the catalog. This is where you find out whether the quality that was fine on 5% of your data still holds at 50%. And this should be a relatively easy upgrade because architecturally there's nothing changing. You're just increasing the scope. You're just widening the scope. Later, add the next stage in the pipeline, but only once your usage data tells you people are hitting the ceiling on the first one. Every stage you bolt on multiplies both your compute cost and your failure surface. So remember, here we kind of want to emphasize on the metrics that we mentioned earlier. Much later, specialize. Fine-tune on your domain, optimize latency, move on device if the product generally needs it. Remember, Pinterest didn't build those fashion heads until generic embeddings were visibly failing on their highest intent category. And Apple's 4 millisecond on-device recognition is a decade of silicon work, not a sprint. Between each of these steps, the question is the same. Did the last version actually get used? And did the thing it was supposed to improve actually improve? Adoption and repeat rate tell you whether keeping going at all makes sense. 0 result rate and click position tell you whether the next investment goes into recall or precision. And those 2 look identical to a user while needing very different fixes. So now that you've kind of had a very good idea of the imaging world and all that kind of, and how to build it, what to look at and all those things, if you're still debating if you need this for your product, your business, then it might be worthwhile to do this exercise. If you're setting up one of these, it comes down to two questions. First, is there a real demand for this modality in your business? Not do you have images? Everybody has images, but it's rather, do your users have intent that they can't express? Do the users really want to use their images to have a better experience on your product? There's two cheap ways to find out before you build anything. Read your failed searches. Zero result queries and immediately reformulated queries are exactly where text is failing. And if those cluster around visual attributes, patterns, shapes, styles, the one that looks like, you've got a signal. Or run a fake door. Put the camera button in the UI, log every tap, show a coming soon state. And that will tell you like, oh, if given this opportunity, users will use it. The second question you can ask yourself is, which bucket of imaging problem are you actually in? Is it classification, segmentation, retrieval, or similarity? They have different costs, they solve a different problem, they have a relatively similar architecture in terms of setting it up, but they're targeted towards a different value proposition. Prioritize your architecture around the stage that carries your value so that the stage is both fast and accurate, and keeping everything as swappable and maintainable. Let's wrap it up by kind of summarizing everything that we've talked about. eBay searches 2 billion images, Pinterest is a $4 billion business built on an interaction that didn't exist before, Google Lens takes 20 billion searches a month, Deere saves 31 million gallons of herbicides a year, and millions of blind people have descriptions of photos that were unimaginable in 2015. That's a lot of value from something that came out of a person's hypothesis, that data was a problem and not the algorithm. I had a really good time trying to understand this technology and how companies have used it to grow their customers. It is worthwhile to kind of think about what your customer needs before building anything, and it's also worthwhile to think about why something is not working. Hopefully, you also took something away from this. Thank you, Fei Li and the team behind ImageNet for building something so impactful to the industry of AI. Till next time, thank you.